Good morning, good afternoon, and good evening, and welcome to Umlink Energy Speaks Back, powered by Hark. My name is Paul Webb. I'm the founder of B2B Energy, and I'm your host. And weekly, I present to you experts from around the world. Welcome to episode 89, where my special guest today is from Canada and brings us insights into investments into technology he really believes in. Our purpose, as always, is to provide a good understanding of energy management knowledge from around the world, which is available today for us to deliver savings that impact on our planet. On our journey of sharing such knowledge, we would like to thank our sponsors, who are Umlink, who are taking the confusion out of energy management, Park Systems, renowned for their energy software, Clean Energy Revolution for their knowledge and networking through LinkedIn, B2B Energy for the 11-week energy program, Lexus Energy for power management, Led by Vision, who are an LED and a controls company, Watts for electronics and EV transition, Carbon Black Global for their waste to energy initiatives, Cinefex for their insulation coating, and SmartCool for their AC initiatives. And lastly, our certificate partners, Esther Energy. Our special guest today is an expert in investment of technologies and is the CEO of two publicly traded green tech companies. So without any further ado, I give you Ted Konyi. Good afternoon, Ted. How are you today?
Very well, Paul. Good afternoon to you too. And thanks for taking some time with me.
Brilliant. And it's great. I'm saying good afternoon to you, but you're actually in Luxembourg today. So only 1 hour difference. Nice and easy for us.
Yeah, nice and easy for us. Exactly. Yes. Normally I'm in Vancouver, where there's an 8-hour time difference, which makes it a bit more difficult. However, we do a lot of work in the UK. And so I'm pretty much an early bird, and I'll be on phone to the UK at 5 or 5:30 in the morning, my time, right, which is still your afternoon. But
yeah, you don't really have a time zone then, do you, Ted?
No. Well, for the longest period of time, I mean, I've been involved in investment in public markets for 40 years. And when you live in Vancouver, that means you kowtow to the New York time zone, because the markets in North America all revolve around the opening at 9:30. So in Vancouver, that's 6:30. So I guess I was always an early riser, but that makes you an early riser that much more.
Yeah. So Ted, we have met through our LinkedIn community, but I do know of you and your technologies through the UK, as you just mentioned, with Steve. We've done some surveys together. We've met quite a few times, and I understand the background of your business and yourself. So for the benefit of our audience today, could you give us background to yourself and your origin story?
Sure. I'd be happy to do that. So essentially, as I mentioned earlier, I've been in the financial market as an investor, as an angel capitalist or angel investor, serial entrepreneur for close to 40 years. Your audience might not want to know that I actually got my start in the oil and gas business, but it gave me an appreciation for energy. And I became a student of energy when I was involved in the oil and gas business. And so keeping in mind the impact of global climate change and so on, I kind of shifted gears and was very interested in energy efficiency technologies. So 18, 19 years ago, seems like a long time, a stockbroker friend of mine in Vancouver said, "Hey, Ted, you know, we've got this little company. It's got the distribution rights for this technology out of Australia. You should have a look at it." So I did, and distribution rights don't make a public company. Distribution rights and it was just for Canada and of all things, New York State. That was it. And I said to the broker, you know, I like what they're doing. I like the concept, but I'd want to have the technology in the company. So coincidentally, the original inventor of the technology, a guy by the name of Tony Murphy, who was out of Sydney, Australia, was about to do an installation in California for his then California distributor. So I flew down. For anybody that is a wine aficionado and seen Sideways, which takes place in Solvang, California, which is a very, very cute alpine-like town north of Santa Barbara. This is where Tony was doing an installation of Abbottly technology, which I renamed to SmartCool technology. And it was at a small grocery store called El Rancho Market, and I watched him do the install, and I thought, okay, that's not too technical. We then did 3 days together, in fact, in Southern California, because he was working with his distributor, and we went and did a number of sales calls. And that particular area is kind of like the berry growing area of the US. In the winter in New York, berries that you might see, strawberries, blackberries, blueberries, whatever, they all come from the valley, which is just north of. And as you're probably aware, anytime vegetables or fruit come off of the where they're grown, whether it's trees or ground plants or whatever, they have to be refrigerated. Mm-hmm. That's what keeps them from spoiling, getting ripe too fast. So they're typically refrigerated in these large, cool refrigerated warehouses. Usually the CO2 levels are high because that also retards the ripening process. So they have a lot of big cooling facilities. And we visited quite a number of them on that 3-day trip. And long story short, which, I'm already past that, Tony was a great guy, but he was an engineer. And, we all have our specialties, and engineers typically aren't finance people. And engineers typically aren't salespeople. No disrespect to
or commercial in any way.
Yeah, or commercial in any way. And, no disrespect to engineers. They're an extremely valuable part of our, standard of living, and they're responsible for so many advances that we all benefit from.
Yeah.
But, I said to Tony, I said, this is a great product that you've got. What's your plans? Well, Tony was running a lifestyle business, meaning, he had sales of, in US dollar terms, maybe $1.5 or $1.7 million a year. He had a good profit margin. He basically farmed out the manufacturing. He farmed out the distribution. He had his daughter working for him, and he had a great lifestyle. They had a place on the ocean in Sydney. And anyway, I convinced him, which I have a tendency of being able to do both from a positive perspective and sometimes to my detriment, that he should consider rolling into this little public company all of the technology. We were in the midst of having a conversation about that, and then we're talking 6 months on. And unfortunately, Tony passed away.
Oh.
64 years of age. And so we carried on the conversation subsequent to that with the estate, and we ended up buying the technology from the estate. We lost the brain trust, right? So we had to hire a bunch of engineers to assist us. But we inherited the UK distributor, which at the time Stephen was working with and was a minor partner in.
Right.
And so right away, even though I wasn't involved directly in management, I was the largest funder that, contributed to buying the business. Right away, I got to meet Stephen and the team and whatever in Alton, and was excited about what they were doing. They were quite successful in their own right, including, initial installations at Sainsbury's and I think also at I'm trying to remember the other large UK grocery store chain. Doesn't matter. Anyway, they were quite successful, and so I was quite excited about that. And so I raised I don't know, $15 million, I guess, to both acquire the company, start to really put a strategy in place to build it, hire some engineers to progress the technology. And then 2009, decided that we really liked what they were doing in the UK, and so we're the distributor. Right. So it's all kind of come under the one banners, and the two owners, the father and son owner of the company, took their proceeds and basically left, and that left us Stephen to kind of run the UK operation, which was great. Stephen's a fantastic guy. He understands the product intimately. He's a hardworking, creative individual, and as we continue with this story, at the moment he is tremendously overworked. A lot has transpired in the 18 years since I first met Tony Murphy, and on the negative side, I kind of call it a perpetual startup. And other people that you talk to, I'm sure, have experienced exactly the same thing. The energy efficiency business, you think on the surface of it, it'd be a no-brainer.
Yeah.
But I continue to be amazed by companies that say no when we target payback periods of 2 to 3 years, and in some cases less than 2 years. Well,
obviously you got the 2 to 3 year payback. What is the percentage of savings that your technology makes on that, say, the air conditioning side?
So it varies. It varies on the type of equipment that we're installing on. If it's like in North America, it's primarily what they call packaged units. These are boxes that sit on a rooftop, and they've got 1 or 2 or sometimes 4 compressors in them, a supply fan, and they basically push the outdoor air or the return air past the which is cold. On those, I would say on average, we're probably 15 to 20%.
Right. Significantly.
And yeah. But again, key is, what are the utility rates? The lower the utility rate, the longer the payback.
Yeah.
Which is why percentages, we tend not to talk about percentages, we tend to talk about paybacks, because they really relate to, well, 1, the economic return that the customers are going to look for, and 2, it relates to the energy cost. However, the exciting part for me, and where ultimately I think that we've got a lot to offer, is with heat pumps. It's counterintuitive to think that a UK technology that is admittedly primarily focused on air conditioning, although it has application for commercial refrigeration as well. And commercial refrigeration, of course, is typically a 24/7 operation, 24/7, 365 operation. But air conditioning in the UK, 3 months, 4 months a year, kind of like Canada, not very much. And so that makes the payback period much longer, makes the return on investment lower. So heat pumps, however, and you'll catch me smiling, because heat pumps are like refrigeration. Basically, if you want heating, as opposed to, traditionally in the UK, it's boilers for commercial operations. Mm-hmm. If you want heating with a heat pump, you're basically reverse cycle air conditioning. And we're as effective on the heating side in that scenario as we are on the cooling side. In fact, what really surprised us in many respects was some work we did now 4 or 5 years ago. The first heat pumps we really installed on, and we had to do heating because it wasn't perfect at that time. But one of the very first, if not the very first, heat pump installation we did was for a water utility in the Midlands at their campus, as they call it, right, their office complex. And we had done a number of their chillers. No refrigeration, but we did a number of their chillers. And then on one building, they had placed their boilers and chillers with Mitsubishi heat pumps. They were pretty sizable. And after we finished the installation, the customer called and said, "Hey, you're getting some great results here." And we said, "Well, how do you know that?" One, they were measuring circuits, power, but they had sub-metered their circuits. And he said, it's looking like 60%. And our first thought was, oh my God, we've done something wrong.
You turned it off.
We've basically turned. Yeah, I mean, that's the best way to get energy efficiency.
Exactly. That's the whole
Just
idea.
don't consume any kilowatts.
Yeah.
The people inside the building might not be happy about that, but it's a good way to save energy. So the next question was, well, have we affected temperature? And they were metering temperature as well. I said, no, everything's perfect. Everything's perfect. So we realized that because modern heat pumps are all inverter-based variable frequency drive systems, we had more ability to do what we have done right since Tony developed the software with heat pumps, because you could vary the speed of the motor and thereby, in fact, increase the savings. So, that's a kind of a rapid discussion of the evolution from I met Tony Murphy to the present day. About the same time as we acquired the UK distributor, we kind of downsized Tony's original model, which was, named the ESM system. Brilliant branding, energy savings module, which was really focused on multi-compressor systems, rack systems in grocery stores, where you might have 4, 6, 8 compressors, and the system could handle and better manage those 8 compressors and got savings as a result of it. So then we kind of, if you will, downsized the algorithm so that it would work with single and dual compressors, which were far more prevalent in the rooftop units that you find in North America. And of course, now far more prevalent with heat pumps. So that's been a really good development. We're now in our, I think, 25th version of the software. So we've continued to enhance it and so on. We've got a new unit coming out, hopefully in the next 3-4 months. They've been bench testing it for some time. It's actually a UK-based development group, RF Controls, that we've worked with in the past. And I guess now 2 years ago, we started down the path of developing something that would incorporate what we need for the heat pumps, which typically when we install our older, what we call our Eco 3, we incorporate a programmable logic controller with it.
Yeah.
And the interface is simply the third-party control that the heat pump manufacturers already provide. So in Mitsubishi's case, it's a very simple adapter cable. In Daikin's case, it's a card, PC board that allows third-party control the working of the system, and that eliminates any concerns from a warranty perspective. That basically these third-party controls already have limits in terms of what can and can't be done, and we simply work within those limits. So you have a heat pump that needs to be controlled by a building automation system. They use the same adapter cable that we use.
So Ted, I understand the all the different applications where we can apply this. Is there a way that you can share the science of how the technology works, or is that a secret within the company?
Well, listen, it'll remain a secret when I tell you, because I'm not an engineer.
Okay, well let me hear the sales pitch of what I mean.
So the layman's version, right, which is me in this case, is that when you've any way that you're going to either with a heat pump use it for heating or for air conditioning, you're really working off of the physical properties, the physics of refrigerant, which has a low boiling point. So you're depending on state of change from liquid to gas to liquid. Because it's a low boiling point, it absorbs heat So in the evaporator coil, which is where the liquid refrigerant is, if you're talking about air conditioning, air gets passed through the evaporator coil, and the refrigerant, the liquid refrigerant, gets heated up past the boiling point, turns into gas. The gas then goes to the compressor, and it gets compressed back and heated to then be put under high pressure, high heat in the condenser coil, which then distills down to a cold liquid. Okay, so and then it just goes around that circuit again and again.
Yeah.
So that's how the refrigeration system works, or air conditioning works, and essentially a heat pump just reverses the cycle.
Yeah.
Right. The condenser coil becomes the evaporator, and the evaporator coil becomes the condenser. So what do you know that nobody else knows? What do you do that nobody else does? And that's where Tony's brilliance as a refrigeration engineer came to the fore. That essentially what he understood was, even when the compressor wasn't running, you had air going through the evaporator coil or air around the evaporator coil, and as a result, refrigerant was boiling off. But the refrigerant gas had nowhere to go. So now the suction side of the compressor from the evaporator coil would have effectively compressed gas, because the gas had nowhere to go. So gas keeps coming at it, but it's got nowhere to go. So what ends up happening is you compress the gas. So when let's use a thermostat as an example, and the thermostat, which is just a simple on-off switch, says, hey, we need some cooling, and sends a signal to the compressor to get started. On the suction side of the compressor, you've got a lot of high pressure gas. Well, a compressor is a fixed volume. I'm a car guy. I use an analogy of a 2-liter 4-cylinder engine. You want to get more power out of the engine, what do? You turbocharge it. What does turbocharging do? It puts more fuel and air molecules into the cylinder under higher pressures, bigger bang, right? Mm-hmm. So in this case, what you've got suction pressure that's very high when you first start the compressor. So more molecules of refrigerant go through the compressor because it's a fixed volume, like a car cylinder. It's a fixed volume. You got more refrigerant molecules going through because it's pressurized, and it's pressurized naturally. There's no turbocharger, right? So that's a natural property of the refrigeration system. Okay, what happens as you keep running the compressor? So, if you've got let me use metric. If you've got, in Canada we do, so if you've got your thermostat set at 21 degrees Celsius, the compressor doesn't get turned on by the thermostat till it hits 22 degrees. And then it says, we need to get some cooling going, sends a signal to the contactor turns on the compressor, the system starts running, right? And then the thermostat, reading the temperature as the room gets cooler and cooler and cooler, it at 20 degrees, so let's say a 2 degrees Celsius gap, it turns off the compressor. The runtime of that compressor is entirely dependent on the load. So you and your wife in your house, you've got an air conditioning system. It's 25 degrees outside. You're just sitting, relaxing, reading a book, watching TV or whatever. The compressor, in order to satisfy your temperature requirement, might go on for 10 minutes and then turn off. On the other hand, if you're having a party and it's 75 degrees and everybody's dancing, the compressor might have to run for 35 minutes to achieve the temperature.
Yeah.
So the system that we have, the algorithm that we have, timestamps the on and off events of that signal. Whether the signal is a simple thermostat, whether it's a building automation system, whatever sends the signal to the contactor to turn on the compressor, we put ourselves in that circuit, and we timestamp the on event and we timestamp the off event. And that the length of time of run and the length of interval between runs are effectively proxies for load. So, should back up a second. The compressor becomes less and less efficient at cooling the longer it runs because the suction pressure keeps dropping. So there's fewer molecules going through. So Tony said, well, okay, so if I know how long it's running and I know the interval that it's not running, then I can do a calculation and say, okay, midway through the run cycle, I'm going to turn the compressor off for 2 minutes, 3 minutes, 5 minutes, 6 minutes, whatever our lookup table suggests, our calculations suggest.
Yeah.
And so what happens then is that the suction pressure when the compressor's back off. Now we're talking about midway through a cycle, midway through the period of time that the thermostat is saying, okay, I'm at 22, I want to get to 20. Midway through that cycle, we turn off the compressor, we intercede, we turn off the signal. And what happens is the suction pressure builds back up naturally. So now we turn it back on 2 minutes, 3 minutes, 4 minutes, 5 minutes afterwards. And you've got back to that point where the compressor is way more efficient because of the refrigerant molecules that are going through the fixed volume. So you're going to get cooling happening faster. So you reduce the kilowatt hours because you are effectively turning off the compressor for some period of time. And you reduce the length of time the compressor runs because you've done it at an optimum level of pressure on the suction side, an optimum level of compressed refrigerant.
And you've increased the efficiency because you're going to make it a lot easier to cool.
Yeah, exactly. So the key point is that compressors in the refrigeration system are most efficient at the beginning of a cycle when it's been off for a while, because there's naturally more pressure in the suction side of the line.
Right.
And they get less and less efficient as they keep running. So
literally, $1 million question. Why isn't the systems designed like that from day one? Or is it because we can't design it from day one because we don't know where you're going to install it?
Exactly. That's the latter is the case, that you've got manufacturers like Mitsubishi and Daikin and Carrier and everybody else that have to provide a very wide range to accommodate whatever the system is going to need. And it's only at the actual location that, and by actually looking at the run times, that you'll be able to do something. So I know where that question leads to. Could the Daikins, the Mitsubishis come up with this? Sure, they could. Absolutely. I've been anticipating a call from one of them. I haven't got it yet, but who knows? Maybe it's going to come.
So Ted, I was involved with a heating system very similar to this. It works in the same scenario, and I always used to ask the question: why isn't the boiler? When I buy a boiler, it doesn't come with that product bolted as part of it? It just doesn't make sense. Why? Because every single air conditioning system in the world would have this, and every single system will be saving that percentage of emissions. Yes.
So you definitely reduce emissions, but of course, going back to square one, I'll back up, has been traditionally an economic decision.
Yeah.
And that's changing. And it's changing pretty rapidly. We're seeing it almost daily, where ESG and carbon footprint reduction is taking far more prominence in the decision-making process by these companies.
Yeah.
One of the biggest property
Sorry, Ted. It was interesting you were saying earlier about the UK only requiring cooling for certain periods of the year. That is changing, that dynamics. We're seeing air conditioning systems and the need for air conditioning systems more and more, and the demand on air conditioning systems. And because of the rate, we discussed the energy rate's gone up circa 200% already this year. And it's not looking to come down. It's looking to keep on going.
Right.
So your systems and technologies are going to be playing a very key part in the future, I believe. Yeah.
Perfect storm coming. Got carbon footprint reduction, got energy rates going through the roof, and are going to continue going through the roof, to your point. The unfortunate conflict that's going on in the Ukraine has changed the world's energy dynamic, I think, for a long time, if not forever.
Yeah.
And so, Again, I'm a keen student of the energy business. I still monitor oil and gas. And, North America is going to become a massive market for us because a lot of places like the state of California and the state of New York are outlawing natural gas in new construction. And natural gas has been the go-to for heat.
Yeah.
So now they're installing heat pumps. It's the electrification of everything from, EVs to heat pumps. And because the rates are going up so much, then the economics are going to be much more favorable. But that's not what's driving it entirely. Like I say, recently we've seen some pretty big companies kind of get on the bandwagon. We're dealing with one of the biggest property managers in the world. And in a couple of projects they've asked us to quote in London, it's almost like they're saying, listen, we don't care if it's a 5-year or 6-year payback. What's the carbon footprint reduction?
Right.
Wow.
That's interesting to hear that.
The breath of fresh air.
Yeah, totally.
Right. I did a quote for this the same property management company because they're managing property for. So this is a company that manages properties for large companies where they don't want to worry about managing all of their various assets. And this one international company that's got operations throughout North America, in Italy, in Hungary, in the UK. The property manager basically came to us late last fall, and I put a quote together for all of the 5 locations that they had in the US. And after it got presented, a month later, they came back and said, hey, could you, I'd set the threshold at what I thought was realistic in terms of payback period, 2.5 years. And they basically came back and said, hey, you only recommended that we put your technology on, I think it was 66 out of 230 rooftop units they had on the 5 locations. Could you redo your quote without concern about payback period and more concern about carbon footprint reduction?
Brilliant.
Yeah, so it's happening. As I say, I watch gas prices today. They're all-time high in North America at $9.50 US per 1,000 cubic feet. A year ago it was $3. The year before that it was $2.20. Well, there's a direct relationship between natural gas prices and electricity.
Yeah.
In the US, 40 or 41% of the electricity generated is generated from natural gas. Mm-hmm. You can't have a 300% increase in the input cost without expecting, like you're getting in the UK, a 200% increase in the cost of electricity. So it's good for us. We don't have enough feet on the street. That's one of our biggest issues. We're the typical small company. We've bootstrapped our way along, other than some fundraising that I've done over the years. But we're finally to the point where I think we're going to be quite profitable this year. We've landed some major projects. I'm not yet at liberty. I'm hoping to put out formal press releases. We've asked for permission from 2 very well understood, well-known companies in the UK. And it's really the starting stage. We had successful pilots with both of them last year. I can say that it looks like we're moving forward with King's College. We did a pilot with them last year as well, and they've let us talk about their name. So I'm pretty excited, pretty jazzed.
Let's go back to you mentioned you need more people on the streets. So is that more distributors of your system or more people to go? What do you actually mean by that?
So it's a colloquialism, of course, from North America. Feet on the street is just people knocking on doors, salespeople.
Mm-hmm.
Right. We've tended not to work so much with distributors, particularly in the UK, where we've got a great team headed up by Steve. We still, to this day, do most of our installations. We farm out most of our installations in the UK with our team. But yes, we need more people knocking on doors. And with success, of course, it breeds further success, because a lot of companies don't necessarily want to be first. And if there's a perception that they're first, then they're going to hold off until they actually see that you've got, a big name that's agreed to come on. we did an installation at the largest shopping mall REIT in Canada last year. It's an account that I've been working very closely with a sales agent in Toronto. And Ontario is kind of an exception in Canada in terms of utility rates. BC, where I live, hydroelectric power, it's cheap. So the motivation is low. But in Ontario, they turned down one of their nuclear generators, and they're really promoting green and solar. And so, but it's carrot and stick. And the stick is, yeah, we're going to tax utility rates, and now they're going to be 19 or 20 cents, not 12 cents. So that really has an impact. So yeah, we did an installation, a pilot installation with RioCan. They have 215 shopping malls across the country. And it looks like we're going to really start to roll out with them. Savings were significant. We managed to get the Ontario government energy subsidy for the project. It's one thing that I haven't spent a lot of time with Stephen on, and maybe you're familiar with this. I certainly am not. I'd love to become more familiar with it. In California, for instance, there's a lot of subsidy programs offered by the utilities. And it's counterintuitive, because you think, well, geez, they want to sell power, don't they? Why would they pay you not to use it?
Yeah.
Right.
We don't really see in the UK the power companies getting involved with subsidies or funding of these products. We have a Green Deal in the UK, but we are now seeing a lot of sustainability funding coming from government. And I think we are going to be seeing that a lot in the coming years. And I think that's where the direction is going to be coming from. And it needs to come more. I don't think it's enough still. I think we need to be working on that. Ted, it's come to that time, really. I'm really interested about the technology, and I've been looking at installing that into some of our clients in the UK. And I'm hoping that we can share that globally because we've got global listeners today. So it's come to that time, Ted, where I'd like to see if there's anything you can give back to the industry today regarding the takeaway from your experience.
So I guess the takeaway is stay the course. I mean, as I said earlier, it's like an 18-year startup. I've been committed to this project for a long, long time. People around me, my friends, my business associates, my wife, kind of wonder, come on, you're not making it. But, I continue to convince investors. So I think if you've got a good technology, I think it is a case of stay the course. I think that we're coming into our time as far as energy efficiency businesses. Stay the course.
Exactly. I heard a very interesting story today about Henry Ford when he created the car without the horse, basically. The only person that supported him was his wife. And he had no money, he had nothing. And look at us today.
Right. Everyone's
driving around in cars. Not
yes.
Fords, but he was the one that made it. He stayed the course.
Yes, I agree.
And Edison's another story, when he created the light, the lamp.
Yep.
How many times did he keep on going before he actually got it to work?
Exactly. So, no, we've stayed the course, and like I say, I'm very hopeful, and certainly the indications that are in front of us right now is going to be a very successful year, and I think we'll be able to build on that success.
Well, Ted, I think you've got great technology. I've known Steve for many years, and I believe in what you're doing there, and I can see the benefits of it. I'd like to personally thank you for joining us today. It's been great to catch up, and I hope you get your flight all in time and everything's smooth. So please, I hope your family stays safe in these times.
Thank you very much, and thanks for your time, and appreciate being on the show. Keep up the good work.
Thank you.
All right.